Hello everyone, welcome back. Today we will be entering chapter 2, which is on kinematics of linear motion. Right, so in this chapter you'll have three subtopics that you need to cover. So the first one is on linear motion, where you need to be able to define instantaneous, average, and uniform velocity, as well as for acceleration. Okay, and then you have to be able to discuss the physical meaning of several graphs, for example, displacement time, velocity time, as well as acceleration time graphs. And lastly, you should be able to apply the theory into a questions in which you have to determine the distance traveled, displacement, blah 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 here from appropriate graphs lah. Okay, so let's define them now. So what is actually speed? Speed actually defines how far an object travels in a given time interval. In that case, you will be calculating them using this formula. So what is the difference between speed and velocity? Velocity tells you how far it goes as well, but it includes directional information. Okay, so it includes the direction lah. Ya kasi tahu dia pi mana, dia pi kiri ka, dia pi kanan ka, right? Okay, so for velocity, you'll be calculating it the same way as speed, but you will be using displacement instead of distance lah. So average velocity pula, it is the rate of change of displacement. Instantaneous velocity, it is the rate of change of displacement tapi at that instant, at that time period yang dorang minta. Okay, so this one you can read them by yourself. And then we have acceleration. So acceleration is the rate of change of velocity, whereas instantaneous acceleration is the same, in which it is only for a certain time interval lah. Okay, so right, so deceleration pula, it shows a negative acceleration. So what does a negative acceleration means? It means that the object is slowing down. Okay, so macam kita mau brake lah, bila jumpa lampu isyarat begitu, red traffic light, whatever, red light. So what does acceleration tells us? So acceleration tells us how quickly the velocity changes, whereas velocity tells us how quickly the position changes. Okay, so make sure you understand that acceleration is about velocity, whereas velocity is about position. Okay, now these are some of the questions that being asked by students. So does velocity equal to 0 means acceleration also equal to 0? Well, it's not. Okay, in short, acceleration does not equal to 0 when velocity is equal to 0. Okay, so next one, if acceleration pula 0, if acceleration is 0, does it mean the velocity is 0? No. Okay, it does not mean that. Okay, so velocity shouldn't be equal to 0 when acceleration is equal to 0. Okay, so acceleration may occur due to change in speed, direction, or in both speed and direction lah. Okay, but make sure you understand that uniform velocity means 0 acceleration. Why? Because velocity, acceleration is it's showing the how quickly the velocity changes. Okay, kalau kamu faham yang two sentences ini, kamu akan faham lah the relationship between those two. Right, so let's look at graphical methods. So we have ST graph, VT graph, as well as AT graph. Okay, so displacement against time graph. So what does the gradient of an ST graph tells us? Okay, so if we look at this, distance or displacement against time means it is the speed or the velocity. Okay, velocity if the displacement lah. So this graph is telling us about the velocity. Okay, so if we look at this graph, the first graph here, we can see that the graph line is increasing uniformly. Okay, so what does that mean? The gradient of this graph means it is constant. So what is constant? It means that the velocity at this point is uniform. Okay, so it increase uniformly ka the velocity, gitulah. Right, so this one is gradient. Gradient, the velocity is increasing uniformly. No, the gradient, I mean the velocity is uniform. Right, yang this one barulah dia kasih tahu velocity increases with time. Why? Because we can see that the gradient here keeps on increasing as time goes by. Okay, so yang ini just now dia constant velocity, yang ini pula velocity increases with time. Okay, if we look at this one pula, dia ada banyak point in which you have to tell lah. So at this point Q here, if we look at S, dia ada position change. So the position doesn't change means velocity is equal to 0. Okay, remember velocity shows us how quickly the position changes. And then for this one pula, the distance goes from a higher value going down. It means that the gradient is negative, in which showing us that the direction of the velocity is changing. Okay, so if ada negative tu, maksudnya direction dia is changing lah. Okay, yang ini sama dengan yang di atas lah. Right, so now we are going to look at velocity against time graph. So this one, the gradient is telling us about the acceleration. Okay, acceleration. Okay, so let's look at A. So if we have a graph that shows a straight line during a time period like this, it means that the velocity is uniform. So what does a uniform velocity means? It means that the acceleration is equal to 0. Okay, acceleration equal to 0. Okay, next we look at graph B. Graph B, we can see that the velocity is increasing uniformly with time. So what does that mean? As we know, acceleration shows us how fast, not how fast, what was it again? How quickly the velocity changes. So if we look at this graph, it is showing us how quickly the velocity is changing. Hence, it means that the acceleration is also changing uniformly. Okay? Okay, so for this graph, we are looking at point A the same way as this one. And then we have at point B, in which the other uniform velocity means acceleration is equal to 0. And then at point C, the velocity starts to decrease, in which it means that the acceleration is less than 0, showing a deceleration. Okay, dia sedang tekan brake lah to, time to. Okay, so what does the shaded area telling us? So the shaded area at this point is actually telling us the displacement. So how do we get that? Is by integrating at a time interval. Okay, so T1 and T2 here, we can then integrate in terms of time. We will then get the displacement. Okay, right. So these are some of the graphs for linear motion, in which for xt is actually means st. Okay, which is displacements against time graph. So what does it give us? It tells us the velocity. Okay, the velocity, the gradient tells us about the velocity. Then for velocity against time graph, it tells us about the acceleration. And then for linear motion, ini adalah acceleration against time graph je lah. Okay, so make sure you are able to kind of describe this motion, the graphs, by using this. Okay, by using this, some of the keywords here, right? Okay, let me see if we have another theory. Okay, so that is basically the theory part for 2.1, which is on linear motion.